Dear students, this is the question of JEE Mains Chemistry, and this is the shift of 5th April 2024, and it is a shift of first. It is a question of first shift. Now the question is given below are two statements. One is labeled as assertion and other is labeled as reason. So let us discuss about the question. Assertion given is enthalpy of neutralization of strong monobasic acid with strong monoacidic base is always minus 57 kilojoule per mole. So the enthalpy of neutralization will be taken as the concept accordingly that the strong monobasic acid with strong monoacidic base. This point is the strong monobasic acid and strong monoacidic base. In case of these strong acids and base, the enthalpy of neutralization will be constant, and that is approximately minus 13.7 kilocalorie, and it will be in kilojoule per mole. It will be minus 57 kilojoule per mole. So what will be the reason? So the reason is enthalpy of neutralization is the amount of heat liberated or released when 1 mole of H plus ions furnished by acid, and that will be combined with 1 mole of hydroxyl ions furnished by base to form 1 mole of water. So the acid will release H positive ion and base will release OH negative ion, and it will combine to form 1 mole of water. So it will be the reason. So the enthalpy of neutralization is the strong acid monobasic acid releases H positive ion and strong monoacidic base releases OH negative ion. So it will be correct. So both the statements are true as per the option. Statement B, R is false here, so it will not be correct. A is false here, it will not be correct. Both statement A and B are true, and reason is the correct explanation of the assertion. It will be correct. And the last option is given here. Both A and R are true, but the reason is no the correct explanation of A, so it seems incorrect. So our right answer will be 3. So this is the question of JEE Mains of the first shift as per 2024. Hope so it will be clear. So stay connected for the next question of the series. The question is the number of neutrons present in the more abundant isotope of boron is X. So the more abundant isotope of boron is B510 and B511. So most accepted is B511. So the value of X will be, so here X asked here is the number of neutron. So the atomic mass is 11 and atomic number is 5. So the number of neutrons will be 6. So we can find the number of neutrons by subtracting the number of protons, that is atomic number 5, from the atomic mass 11. So we will get the value of X, that is 6. Then amorphous boron upon heating with air. Now the boron in the presence of air gives B2O3, forms a product, that is B2O3, in which the oxidation state of boron is Y. So we will find the oxidation state of boron. Here oxygen 2 negative, so overall 3 to just 6 negative charge on oxygen, so it will be 6 positive on 2 boron atoms. So the one boron atom will get plus 3. So the value of Y will be 3. So X plus Y, we will get 6 plus 3 is equals to 9. So the answer will be option number 4. Now the next question is the incorrect postulate of the Dalton's atomic theory are atoms of different elements differ in mass. So let us check the correct or incorrect postulates in all the given statements. Atoms of different elements. Suppose we have hydrogen and helium. So one atom is hydrogen and second atom is from the other element, helium. Elements differ in mass, so they have the different mass. So the point number 1 is correct. Matter consists of divisible atoms. Matter consists of the indivisible atoms. Just because atom is the smallest fundamental particle, that cannot be divisible, so it should be indivisible atom here, so it will be incorrect. Next statement, compounds are formed when atoms of different element combine in a fixed ratio. So according to this statement, compounds are always formed by the combination of the different elements. Suppose we have hydrogen and chlorine, they are different elements, they are combining in a fixed ratio. Fixed ratio by mass, we can say more appropriately. So this statement is also correct. Moving towards the next, all the atoms of given element. Suppose we have hydrogen element and all the atoms, suppose we have more than 2 elements of hydrogen atoms, have different properties including mass. That means mass of all the elements of the same, all the atoms of the same elements are different, but this is not possible because all the atoms of the elements have the same mass. So the point number D is also incorrect. Next one is chemical reactions involve reorganization of atoms. Just we have H2 plus Cl2 gives 2HCl. Here these are the atoms like hydrogen and chlorine. They are present in the molecular form, and here they are present in the compound form. And there is the bond breaking and bond making that reorganizes the given elements to form the given compound. So this is a chemical reaction that involves the reorganization of atoms. So this statement is also correct. So we have to find the incorrect postulates of the Dalton's atomic theory. So first one is correct, second one is incorrect, third one is correct, and fourth one is incorrect, and last one is correct. So the incorrect statements are option number B and D. So the option B is correct here. Coming towards the next question, that is, given below are the two statements. Statement 1 is in group 13 in group 13 the stability of +1 oxidation state increases down the group. So if we are talking about the group 13, that is started from boron, aluminium, gallium, indium, thallium. So the +1 oxidation state increases down the group. So the valence electrons in these elements are +3. That is NS2 NP1. That is outer electronic configuration of the elements. So on moving down the group, +1 oxidation state is more stable comparative to the +3. It is just because down the group inert pair effect operates. In which S electrons are less likely to participate in the bonding. So the first statement is stability of +1 oxidation state increases down the group. So only NP1 electron is easily available to lose by the atoms of the group. And the second statement is the atomic size of the gallium is greater than that of aluminium. On moving down the group, atomic size increases if the regular trend follows. But here inert pair effect and the intervention of the D and F block elements, there is the decrease in the size of the elements in the third and fourth transition series. So it will not be possible after boron and aluminium the size of the elements increases. So the size of the gallium is not larger than aluminium. So the second statement is not correct. So the answer will be first statement is correct and second statement will be incorrect. So it will be the answer number 3. Coming towards the next question, the reaction at cathode in the cells commonly used in clocks involves the oxidation of manganese from +4 to +3, oxidation of manganese from +3 to +4, and oxidation of manganese from +2 to +7, and reduction of manganese from +7 to +2. So the reaction involves in the cloak are usually the alkaline batteries. These are the alkaline batteries in which The oxidation takes place at N node. N node means oxidation. So here zinc is getting oxidized to zinc oxide. In alkaline medium, it means plus OH negative gives water, and zinc changes into zinc to positive here in zinc oxide. So there is a release of 2 electrons. And in case of cathode, reduction takes place. So the manganese dioxide changes into Mn2O3. So the manganese dioxide involves plus 4 oxidation state, and Mn2O3 oxygen involves minus 2 negative charge. So overall 6, it will get plus 3 on individual manganese, and the complete reaction will be shown by the overall reaction. So we can identify the oxidation number of manganese in manganese dioxide is plus 4 and Mn2O3 is plus 3. So it will be 4, it will changes from 4 positive to 3 positive. So there is a gain of electron, and gain of electron is the reduction here. So the answer will be 4 positive to 3 positive. Next question is, the following reaction occurs in the blast furnace. Where iron ore is reduced to iron metal. Here reduction from Fe2O3 to iron takes place in the presence of the carbon monoxide, and this follows the Le-Chatelier principle. Using the Le-Chatelier principle, which one of the following will not disturb the equilibrium? So here the pure solid is taken, that is taken as the constant, where concentration of the pure solid is taken as the constant. So it will not affect the equilibrium, and the Le-Chatelier principle involves the change in concentration, change in pressure, and change in temperature on the gaseous and liquid reactant and products. That involves the shift in the equilibrium in backward and forward reaction, forward and backward directions. So the pure solid Fe2O3 is taken as constant, that does not involve a change in equilibrium. So addition of Fe2O3 will be the right answer. The correct order of ligands arranged in increasing field strength. So here are the following ligands which are arranged in increasing field strength. So we have to check the correct order. So correct order will be given by the spectrochemical series. This series involves the following ligand like iodine, bromine, SCN negative, chlorine negative, sulfide 2 negative, fluoride ion, hydroxyl ion, oxalate, water, NCS negative, EDTA4 negative, ammonia, and then ethylene diamine, cyanide ion, and carbonyl ion. So generally in this series or the spectrochemical series, we can follow the two simple rules to solve this question. So first one is arrange the following halide ions. So fluoride ion has greater crystal field strength than chloride ion, which is greater than bromide ion, and then iodide ion. And second rule will be the carbon donor ligands has greater field strength than nitrogen donor, which is greater than oxygen donor, and then halide ions. So let us check the two simple rules in the given options. So first one will be fluorine, chlorine, bromine, fluoride, bromide, iodide, and then ammonia. So here fluoride ion should have greater field strength, but here it is less than bromide and iodide ion, so it will be wrong. Then second, chloride and bromide ion. So here bromide ion has greater, but it should be opposite. Chloride ion should have greater crystal field strength than bromide, so it will also wrong. And in case of water, hydroxyl ion, cyanide, and then ammonia. Here we can follow the donor atoms as carbon containing ligand, that is cyanide, must have greater field strength, but it has less crystal field strength than nitrogen containing ligand, that is ammonia, so it will be wrong. In case of the last one, fluorine has greater field strength than bromide ion, so it will be okay. And then nitrogen containing ligand has greater field strength than oxygen containing, as per the general or the common rule that carbon donor atoms or the ligands has greater field strength, and then nitrogen containing, then oxygen, and then halogen atoms. So the correct answer of this question will be option number 4. Identify A in the following reaction. The given compound is carbonyl compound. In the presence of hydrazine, this N2H4 is written as NH2NH2. This is hydrazine. If simply hydrazine is present, then dehydration takes place. But in the presence of the second reagent, that is ethylene glycol and basic medium potassium hydroxide, then it will follow the Wolff-Kishner reduction. This is a name reaction, Wolff-Kishner reduction. If there is reduction, then carbonyl compound reduced to form hydrocarbon, and hydrocarbon, this compound is containing 4 carbon atoms, so hydrocarbon is N-butane. So this is the interesting question from the chemical reactions of carbonyl compound that follows the Wolff-Kishner reduction. This question is very interesting. Here we have to find out the increasing order of boiling points among the following compounds. So the correct answer will follows the order of the types of interactions in between all the compounds. The first compound is the example of ether. The name of this compound is diethyl ether. Diethyl ether. Second one is given here, N-pentane. So overall 5 carbon atoms are there. 1, 2, 3, 4, 5. So this is N-pentane. And the next one is pentane 3. This is the example of ketone. And the next one is the alcohol, pentane 2-ol. So these following compounds has the types of intermolecular interactions. Intermolecular interactions includes hydrogen bonding in alcohol, dipole-dipole moment in ketone, and weak van der Waals forces in N-pentane, and dipole-dipole interaction in case of ether. So the highest boiling point of the alcohol due to the presence of hydrogen bonding, and the lowest type of intermolecular interactions are weak van der Waals forces of interaction. So highest boiling point of the D and lowest boiling point of the B. So directly out of these two options, if we will check the answer, highest will be D and lowest will be B. And then between A and C, ketone has dipole-dipole, strong dipole-dipole interaction, but ether has normal dipole-dipole molecular interactions. So the ketone has greater boiling point than ether. So the order will be B greater than A, and then C is greater than A, and then D will have the highest boiling point. So the order will be second. That follows B greater than A, which is greater than C, and then D. Generally you can find the answer. Highest for alcohol and lowest for hydrocarbon, and greater than hydrocarbon ether, and then ketone. maybe some confusion is between A and C here. So we can follow the same pattern according to the increasing boiling point of the given compounds. So the concept related to the molecular interaction is like that. Here we are with the next question, question number 70. This question is related to the Coulomb's law. The question says molar ionic conductivities of divalent cation. Divalent cation, it means the cation will be having two positive charges, and anion, their molar conductivities are given. So the molar conductivity of cation is 57 Simon centimeter square per mole, and molar conductivity of the anion will be 73 Simon centimeter square per mole. So what will be the molar conductivity of solution of an electrolyte with the above cation and anion will be? So we have to calculate the molar conductivity according to the Coulomb's law at infinite dilution. So the formula will be molar conductivity is represented by lambda m naught at infinite dilution, that is equals to the molar conductivity of cation plus molar conductivity of anion. So this is the formula we can apply directly. So we can add the values of the molar conductivity of cation and anion, 57 plus 73. So it will be approximately 130 Simon centimeter square per mole. So the answer will be 2.